Most people think gravity is a force. You drop something, it falls. So you imagine an invisible pull dragging it downward. That picture feels obvious, natural, correct. But it's wrong. Gravity is not a force. And once you see why, your understanding of time, motion, and reality itself changes. So let me ask you one question. If gravity doesn't pull, what is it?
For centuries, physics treated gravity as a force between masses. And it worked. Cannonballs landed where predicted. Planets followed stable orbits. The moon stayed in place. The math was perfect. But there was a problem hidden underneath. Forces need a mechanism. They push, they pull, they transmit influence. So here's the contradiction. How does gravity act across empty space, instantly, without anything carrying it? How does the Earth reach across millions of miles of vacuum to pull on another object? Even Isaac Newton was disturbed by this. He admitted he had no explanation for how gravity worked. Physics ignored the problem because the equations were useful. Until someone stopped trying to fix gravity and questioned it instead.
Albert Einstein asked a dangerous question. What if gravity doesn't pull at all? To answer it, he abandoned a basic assumption that space and time are passive backgrounds. They aren't. They are part of reality itself. Together, they form a structure called spacetime, and spacetime has shape. Here's the key idea. Gravity is not a force. Gravity is the shape of spacetime. Mass and energy do not reach out and pull objects. They change the geometry of the universe around them. Objects are not pulled inward. They move straight, but in curved geometry, straight paths appear bent. When a planet orbits a star, it is not being dragged. It is following the straightest possible path through curved spacetime. The same is true for you. Your body wants to move straight. The ground prevents that motion. What you feel as weight is not gravity pulling you down. It is the Earth blocking your natural path. If gravity is geometry, why does it feel like a force? Because you never see space-time. You only see motion. Your brain interprets falling and pressure as pulling. The cause is invisible. And once space bends, time has to bend too. You cannot curve space without curving time. The stronger the curvature, the slower time flows. This is not theory. GPS satellites orbit higher than you, where gravity is weaker. Their clocks run faster. If engineers didn't correct for this, navigation would drift by kilometers every day. Time is already breaking around you. Even your body isn't synchronized. Your head is farther from Earth's center than your feet. Time passes slightly faster at your eyes than at your ankles. The difference is tiny. But it's real. Time is not universal. It is personal. Now, push this to the extreme. A black hole is not an object with strong gravity. It is a region where space-time curvature becomes overwhelming. Near it, time slows dramatically. Light bends. Paths collapse inward. At the event horizon, space and time exchange roles. In everyday life, you move freely through space, but are forced forward in time. Near a black hole, moving inward becomes as unavoidable as moving into the future. Escaping isn't like running away, it's like trying to stop tomorrow. The geometry decides, not a force. So look around you. The world feels solid, stable, flat. But that's an illusion your brain creates to function. In reality, you are moving through a curved structure that decides which paths, which motions, and which futures are possible. Gravity is not pulling you down. Space is not empty. Time is not universal. You are living inside a geometry that quietly shapes everything you experience. And once you see gravity this way, the universe never looks the same again.